All right, for this part, we got some coordinate geometry. So you can see what I wrote in blue is my slope formula, my midpoint formula, my distance formula. So the slope of AB, if it's passing through these points here, my change in y is going to go from -8 to 17, so that's going up 9. And my change in x goes from -4 to +2, so that's up 6. I want to reduce that to 3/2. Remember, if you don't know how to look at those and do the mental math to figure out how y went from 8 to 17, which means up 9, you just subtract the second one, take the second y minus the first y, so 17 minus 8 would also get you that. The midpoint of AB, there's the formula, but let's think of this as the average of the x's and the average of the y's. So when you average the two x coordinates, you're going to add them and divide by 2. When you average the two y coordinates, you're going to add them and divide by 2. So you're going to get -2 divided by 2 and 25 divided by 2, which is -1 and 12.5. As far as the length of AB, we could use the change in x squared, which we already figured out when we did slope is 6, and the change in y squared, which also was figured out when we did slope, is 9, so that's going to be the square root of 36 plus 81, which is the square root of 117. As far as the equation of AB, I'm going to do that based on the slope of AB being 3/2, and then use either point from up there. So if I use point A, which is -4/8, and plug that into a point slope form, that's going to come out to y minus 8 equals 3/2 x minus -4, which is really just +4. So I want to get this in slope-intercept form, so I'm going to distribute the 3/2 on the right side. So that's going to give me 3/2 x plus 6. And then when I add 8 to both sides, it's going to be y equals 3/2 x plus 14. Now as far as 37 goes, the slope of any line parallel to AB, it's going to have the same slope, which is 3/2. And any line perpendicular is going to be the opposite reciprocal, so -2/3.